Hello, students. I am Swayam. I am a student at AIIMS Bhubaneswar, currently pursuing my MBBS. So, today we'll start with the part 2 of chemical kinetics PYQ discussion. We'll start with question number 18. Okay. We had covered till question number 17. So, let's start with question number 18. I hope you all have revised all the formulas regarding this chapter. So, it will be easy for you to understand the concepts. Okay, so let's start with question number 18. Question number 18 asks N2 plus 3H2 gives rise to 2 ammonia. The correct option is okay. Options are given as the rate of disappearance and rate of appearance of the product and reactants. Okay, so if you write in the form of rate of disappearance and appearance, we will get the reaction given is nitrogen plus 3 hydrogen gives rise to 2 ammonia. If we write in the form of rate of disappearance of reactants and rate of appearance of products, it will be written as minus dNt. Well, rate of reaction is equal to minus dNt by dt is equal to minus 1 by 3 dH2 by dt is equal to plus 1 by 2 because it is on the right segment. It is a product, so it will be increased in the future, so it will bearing a positive sign. So half dns3 by dt. Okay, so from the options, let's see which one of the options matches this equation. Minus 1 by 3 dh2 by dt, okay, this is here, is equal to minus half dns3. No, it will be a plus side. So option A is incorrect. Minus dn2 by dt, okay, it is here, is equal to 2 dns3 by dt. It is also incorrect. Minus dn2 by dt, yes, it is there, is equal to plus 1 by 2 dns3 by dt. Yes, 1 and 3 are equal. So option C will be correct. So question number 18, correct option is C. Half-life period of a first order reaction is 1386 seconds. The specific rate constant of the reaction is okay. Question number 19. It is given that T half, it is a first of all, it is a first order reaction. And the given information is T half is equal to 1386 seconds. It is asking us what is the rate constant for this reaction. We know the relation between T half and rate constant. What is that? T half is equal to 0.693 divided by K. T half is given. Okay, T half is given to us. We need to find out the K value. So put the T half value here. T half given 1386, 0.693 divided by K. So K will be 0.693 divided by 1386. K will be equal to zero point 0.5 because it is 2, uh, 2 into 10 to the power minus, sorry, 2. Okay. 0.5 into 10 to the power minus 3. Okay. So the correct option will be option B. Let's know the relation between K and T half for other order of reactions. For zero order, T half will be related to both initial concentration and the K value. So it is written as A naught divided by 2K. It is for zero order. For first order, we know it is 0.693 divided by K. For second order, it will be 1 by K, K naught. K naught means initial concentration of reactant. Got it? So option B is correct. Let's move on to question number 20. For the reaction A plus B gives rise to products, it is observed that, okay, on doubling the initial concentration of A only, first write down the reaction. The first statement says that on doubling the initial concentration of A only, the rate of reaction is doubled. Okay. So the uh, just a minute. First of all, write down the rate law. Okay, rate law for this reaction will be K into A to the power X, B to the power Y. We can't write A to the power 1 and B to the power 1 because we don't know if it is a elementary reaction or it is a complex multi-step reaction. Okay, so we have to write in the form of X and Y. We have to find X and the value of X and Y. So the statement given in the first one is on doubling the initial concentration of A only. Okay, so they double the initial concentration of A. Okay, but B is constant. So write down the form here. So the rate will be R1 is equal to K. Doubling the rate concentration of A means 2A to the power X, B to the power Y. Let's suppose give this equation number is equation 1. So R1 and it is R. Okay. So equation number 2 it is. So let's divide R1 divided by R2 equation. Equation 1 divided by 1, 2 will gives rise to R1 by R2 K AX BY K 2AX BY. R1 is R, R2 is 2R because it is doubled. So KK BY A to the power X 2 to the power X A to the power X. So it cancels out, R cancels out. So eventually 2 to the power X is equal to 2. So comparing these two, we get the value of X is equal to 1. Okay. So we got the value for X means A to the power 1 will be the answer for statement number 1. Okay. For statement number 2, on doubling the initial concentration of both A and B, there is a change by a factor of 8 in the rate of reaction. Okay. So here they doubled both initial concentration of A and B, means 2A and 2B. Here rate becomes 8 times, means 8R. R3 becomes 8R. So let's write the formula. R3 is equal to 2a to the power x. X means 1 and 2b to the power y. Let's give this equation as 3. Equation 1 divided by equation 3 will be r1 by r3, a to the power 1, 2b to the power y, sorry, 2a to the power 1, 2b to the power y. So R3 is 8 times that of R. So R1 is R, R3 is 8R, A 1 by 2 into B to the power Y, 2Y, BY. 2 cancels out 4. 1 by 4 is equal to 1 by 2Y. So 2Y become equal to 4, that is equal to square of 2. So the Y value is 2. So finally the rate law would be A to the power 1, B to the power 2. Okay. So option A will be correct. But it is a very long process that I told to you. If you want to do it in a shortcut manner, you can do it. So let's see the alternate method. Okay. So the rate law would be A to the power X, B to the power Y. Okay. If we keep B constant and double the A. Okay. We are doubling the value of A means 2x ax. Okay. It is becoming 2r. Okay. What will be the value of x so that the 2r will be like r will be doubled? Means if we put 2 to the power 1, then it will remain as 2 and it will double the amount of r. Okay. You can use this type of normal analysis to find out the value of x or y. Okay. You don't have to divide equation 1 and 2, equation 2 and 3. You don't have to write this much also. I just wrote because you can know in detail what is happening. Okay. So let's move on to next question. Question number 21. The bromination of acetone that occurs in acid solution is represented by this equation. Okay. What is the equation given? CH3COCH3 plus bromine gives rise to CH3CO CH2Br plus H plus bromide ion. Okay. Kinetic data are given. So let's analyze this data and find out the rate law of this reaction. Okay. So for concentration, if you write, notice row 2 first. Okay. Notice row 2. In row 1, the concentration of CH3CO CH3 is 0.3, of bromine is 0.05 and H plus is 0.05. In row 2, only the bromine concentration is doubled. So let's um, analyze the change in the rate of reaction. Okay. If we double the concentration of bromine, the rate of reaction is unaffected. Look at the below part. The initial rate was 5.7 into 10 to power minus 5. If you double the concentration of bromine here, the rate remains same. That is 5.7 into 10 to the power minus 5. Okay. So, what will be the relation of bromine? In rate law, it will be Br to the power 0. The rate law doesn't depend on the concentration of bromine. Okay, it is unaffected by the changes in bromine concentration. So let's see for H plus concentration here. Notice row number 3. Okay, in row number 3, the concentration of H plus is doubled. That uh, that is 0.1. Notice the change in the concentration of their rate of reaction. 5.7 into 10 to the power minus 5 becomes 1.2 into 10 to the minus 4. That is almost double. Okay, that is almost double. So H plus, if you double the concentration of H plus, then the rate is also getting doubled. That means H plus has a superscript of 1. Okay, if we increase or double the concentration of H plus, if we use superscript 1, then it will double the rate. Okay, so H plus has a superscript of 1. We get that. Now notice for CS3CO, CS3. Okay, the changes in CS3CO, CS3 concentration is can be seen in the last row. So the changes is 0.4, and hydrogen concentration is also doubled. Okay, so here we can write when hydrogen concentration was 0.10 and the CS3CO CS3 concentration was 0.3. The rate of reaction is was 1.2 into 10 to the power minus 4. Now it becomes 3.1 into 10 to the minus 4. We know for doubling the concentration of H plus ion, the rate of reaction would have doubled, but it, but the 1.2 is not doubled here. Okay, so the rate would have become 2.4 into 10 to the power minus 4 if hydrogen concentration is double. But here we can see the concentration of CH3CO, CH3 also change. So if we divide 3.1 into 10 to the power minus 4 divided by 2.4 into 10 to the power minus 4, we'll notice the amount would be 4 by 3. Okay. So if we can increase the concentration by mn to increase the concentration of CH3CO CH3 by 4 by 3, then the rate of reaction also increasing by 4 by 3. That means the superscript for CH3CO CH3 will also be 1. If we increase by 4 by 3, the superscript will be 1 and rate of reaction will be 4 by 3 of R. So both superscript for H plus and CH3CO CH3, both superscript will be 1. So order of the reaction would be 1. Let's write the rate law. Rate law for this reaction would be K CH3CO CH3 1, bromine 0, and H plus 1. In which option this equation is present? Option A. Okay, option A has this equation, but if you convert this BR2 to the power 0 to 1, it will match the option A. So option A will be the correct answer. So let's, here you can notice the rate is also dependent on the product part. Which is a product? H plus, and it is independent of a reactant part, that is bromine. So this way can also the rate can be determined by the product concentration. Okay, so let's move on to next question. Question number 20. The reaction of hydrogen and iodine monochloride is given as hydrogen plus iodine chloride gives rise to 2 hydrogen chloride plus iodine. The reaction is of first order. Okay, the reaction is of first order. With respect to hydrogen and iodine monochloride. Okay, both iodine monochloride and hydrogen have superscript of 1 according to this rate law. If we write the rate law, we'll find out A1, B1. Here A is hydrogen and ICl. Okay, the reaction is of first order with respect to hydrogen and iodine monochloride. So the rate law would be this. But which of the mechanism would match this rate of reaction? So mechanism A is given as hydrogen plus 2 iodine monochloride gives rise to 2 HCl plus I. That means it is denoting that it is a elementary reaction. And for elementary reaction, we use the stoichiometric coefficient as the superscript. So for mechanism A, the rate would have KH2 1 but ICl 2. Okay, but it is not matching the correct rate law. That is H2 to the power 1 and ICl to the power 1. So mechanism A is incorrect. Let's see mechanism B. Mechanism B has two steps, one slow step, one fast step. The slow step has reaction of H2 plus ICl gives rise to HI. Then reaction 2 has HI plus ICl plus gives rise to HCl plus iodine. Okay. But we will take into consideration the slow step. The slowest step determines the rate, determines the rate of reaction. And it is considered as a elementary reaction. So for mechanism B, the rate will be decided by the slowest step H, K, H2 to the power 1 and ICl to the power. So this mechanism matches the correct rate for this reaction. Okay. So mechanism 2 or mechanism B is correct for the above reaction. Okay. So what will be the correct answer? Option D. Okay. So let's move on to next question. In a first order reaction, in a first order reaction, A gives rise to B if K is rate constant. Okay. Reaction is given as A gives rise to B. Rate constant is K. Initial concentration of the reactant A. Okay. A naught is given as 0.5 molar. Then the half life. It is asking T half. For first order, we know uh, the half life formula. T half is equal to 0.693 by K. Okay. This will be the formula, but it is not asking in this form. So let's write the proper form. For first order reaction, ln2 ln A naught by A is equal to KT. That is T half T. For T half, for T half, KT half, the concentration of reactant would be halved. So ln A naught, what will be the A value? A value will be A naught by 2. So A naught by 2. Okay. So KT half will be ln A naught ln 2. So the T half value will be ln 2 divided by K. The option A will be correct. If we option A, I'm writing. But if we write in the form of log 10, then it will be 2.303 log 10 to divided by 2.303 into 0.3010. This value is 0.69. Okay. The multiplication product will be 0.69 divided by. So here learned the derivation also. Okay. So let's move on to next question. Question number 24. Before that, I want to tell one concept of molecularity and order of a reaction. So what is molecularity? Molecularity is the is like how many molecules are involved in in this reaction for the formation of product, and it is a theoretical concept. But of a reaction is a experimental concept. Order of a reaction we find we find by a experiment. Okay, but molecularity is a theoretical concept. So what will be the difference between them? It is a theoretical concept, but it is a experimental. What will be the value of molecularity? Can it be negative? Can it be fraction? No. It is always a whole number. Okay. So it can't be 0, fraction, or infinity, but it can be 0, positive, negative, fraction. Okay. Order of a reaction can be 0, positive, negative, or any fraction. Okay. So let's move on to next question. Question number 24. If 60% of a first order reaction was completed in 60 minutes, 50% of the same reaction would be completed approximately. Okay. So given is 60%, means if the earlier amount was 100, A naught was 100, now A is 40 or 60. It will be 40 because it is completed by 60%. Okay. So remaining would be 40. So let's write down the equation for it. Ln A naught by A, or write this way, 2.303 log 10 A naught, that is 100 by 40, is equal to K into time. What is the time given? 60 minutes. Equation 1. For 50% of the same reaction would be completed in approximately. Okay. Write down the A naught. So A naught would be 100 here. 50% completed means remaining would be also 50. If we write the equation for it, 2.303 log 10 100 by 50 equal to K into okay, time is equation 1, 2 divided by 1. So log 10, it is 2, log 10 2 divided by log 10 10 by 4 means 5 by 2 is equal to 60 by t. Log 2 is 0.30. Log 10 means log 5 minus log 2. If we convert this, it will be log 10 5 minus log 10 2. 60 by t. So 0.30 log 5 value is given 0.69. Log 2 we know 0.3. 60 by t. 0.3 minus 0.69 minus 0.3 means 0.39. So the t, if you calculate, it will be around 40.3 minutes. Okay. The correct answer will be t equal to 45 minutes. Or else you can find out the k value. You can find out the k value from this equation, the equation number 1, because all of the other like variables are given. Okay. So if we'll find out the k value for this one, and the question is asking 50% completion means we have to find out the t half. So after that you can use 0.693 by k for t half. Okay. So whichever method finds you easy, you can apply that. Okay. So let's move on to next question, question number 25. For a first order reaction, A gives rise to B, the reaction rate the reaction rate at reactant concentration of 0.01 molar is found to be 2 into 10 to the power minus 5 mole per liter per second. The half-life period of the reaction. So first of all, write the reaction, and it is asking the half-life period. Okay. So reaction is given as A to the power, A gives rise to B, and it is a elementary reaction. Okay. Reactant concentration is given as 0.01. The rate of reaction is given as 2 into 10 to the minus 5 at this reactant concentration. It is asking for T half. What is the T half formula? T half formula is 0.693 by K. But for T half, we need to find the K value. K value is not given. How can you find the K value? So look at this. Rate for this reaction would be K into A to the 1. Rate given is 2 into 10 to the power minus 5 K. And the concentration given is 0.01 to the power 1. So K value would be 2 into 10 to the power minus 3. Okay. So K value is got. Put it in this reaction. In this equation. T half 0.693 divided by K 0.693 divided by 2 into 10 to the power minus 3. That means 693 divided by 2. That will be around 347 seconds. Okay. So the half-life period we calculated 347 seconds. Option D. Let's move on to question number 26. The rate reaction between two reactants A and B decreases by a factor of 4 if the concentration of reactant B is doubled. The order of this reaction with respect to reactant B is. Okay. So there are reactant A and B. If we write a rate law for them, the rate law would be K into A to the power X, B to the power Y. Okay. Then A and B decreases by a factor of 4 if the concentration of reactant B is doubled. Okay. Rate will be decreased by a factor of 4. That means rate will become R by 4 if we double the concentration of B. So A remain constant. If we double the reactant B, it becomes R by 4. Equation 1, equation 2. Divide equation 1 with equation 2. We get R divided by R by 4. K into A to the X. B to the power Y. K into A to the power X. 2B to the power Y. R 4. B to the power Y equal 2 to the power Y. B to the power Y. That means 2y 2 minus y is equal to 4. That is equal to 2 to the power 2. So minus y is equal to 2. Y value will be minus 2. So in according like with respect to B, with respect to the product B, sorry, reactant B, the order of the reaction would be minus 2. Okay, so option B is correct. That is minus 2. Question number 27. The rate of a first order reaction is 1.5 into 10 to the power minus 2 mole per liter per minute at 0.5 molar concentration of the reactant. It is same as that of question 25. So here it is given that the rate of the reaction is given 1.5 into 10 to the power minus 2 at the product concentration 0.5 molar. It is asking for T half. So for T half, we know the formula of 0.693 divided by K. Got it? We need to find out the value of K. So if we write in the formula Ka, it is the rate law for this reaction. So 1.5 into 10 to the power minus 2 K. A value, A concentration, that is 0.5 molar. K will be 1.5 into 10 to the power minus 2 divided by 0.5 molar. 0.5 cuts it into 3. So K will be equal to 3 into 10 to the power minus 2. We found the K value, but we need to find the T half value. So T half would be 0.693 divided by K, that is 3 into 10 to the power minus 2. It will be 23.1 minutes. So T half is equal to 23.1 minutes. Option B. Next question. If the rate of the reaction is equal to the rate constant, the order of the reaction. Okay, given is rate of the reaction. Let's suppose the rate of the reaction is K A to power X. But here rate of the reaction is equal to the rate constant. That is R to R equal to K into 1. So what is the order of the reaction? A to the power X is equal to a 1. That means, so what will be the value of X? So that A to the power X will be 1. So X value is 0. It is a zero order reaction. Okay. So option B is correct. Statement based question, very important. 29. The correct, correct difference between first and second order reaction is that difference between first order and second order. The rate of a first order reaction doesn't depend on reactant concentration. It depends. It depends by a factor of 1. The rate of a second order reaction does depend on reactant concentration. So the statement, the first half of the statement is incorrect, but the second half of the statement is correct. So option A is incorrect. Okay. For both, like I'm writing the correct information here. For both first order and second order, they depend on reactant concentration. The half life of a first order reaction doesn't depend on A naught. Okay, it is correct because the half life of a first order reaction is 0.693 by K. It doesn't depend on the reaction, the concentration of reactant. The half life of a second order reaction does depend on A naught. Yes, it depends on A naught as T half is equal to 1 by A naught K. Okay. For second order reaction, T half is 1 by A naught K. So it does depend on the reaction, like concentration of A naught. Okay. So option B is correct. Let's read out the rest of the options also. The rate of a first order reaction does depend on reactant concentration. Yes, it is correct. The rate of a second order reaction doesn't depend on the reactant concentration. No, it is incorrect. For both first order and second order reaction rate, they both depend upon the reactant concentration. Okay. A first order reaction can be catalyzed. A second order reaction cannot be catalyzed. No, it is incorrect. All type of reaction, whether it is third order reaction or fourth order reaction, it doesn't like depend on the order of the reaction. Okay, you can catalyze any order in any order reaction. Okay, so option D is incorrect. Question number 30. The reaction A gives rise to B follows first order kinetics. Okay, it is first order kinetics. The time taken for 0.8 mole of A to produce 0.6 mole of B is 1 hour. Okay, the time taken for the first of all write down the reaction. A gives rise to B. zero point 0.8 mole of A to produce 0.6 mole of B means 0.6 mole produce means 0.2 remain. Okay, time is 1 hour. Then what is the time taken for conversion of 0.9 mole of A to produce 0.675 mole of B? A gives rise to B. First initial concentration is zero point 0.9. Okay, first initial concentration of A is 0.9. Here B is 0. It produces 0.675 mole of B. So it is remained as 0.225. So write down the equation for both. The time is asking. So write down the equation for both. 2.303 log 10 0.8 by zero point 0.2 because a naught is 0.8, a by like a is 0.2, 0.2 is equal to 1 over equation 1. Equation 2 will be 2.303 log 10. A naught is 0.9, a is 0.225 is equal to kt. Divide equation 1 by 2. So log 10 0.8 by zero point 0.2 log 10 0.9 by 0.225 is equal to 1 by t. So 0.2, 0.24, it is also 4. So log 10 1, log 10 1. No, log 10 4. Log 10 4, log 10 4 d is equal to 1 by t. Log 10 4, log 10 4 cancels out. T is equal to 1 hour. So the time required will be 1 hour, same as that of the first situation. Okay, so option B is correct. Question number 31. Ta gives rise to B plus C. It would be a zero order reaction. Okay. So we have to find out the condition for becoming a zero order reaction. The rate of reaction is proportional to square of a concentration of A. Okay. The rate of reaction is proportional to square of concentration of A. That means it is a second order reaction, not a first order reaction, because the superscript is 2. In for zero order reaction, it doesn't depend on the rate of reaction, doesn't depend on the initial concentration of reactant. Okay, it is a constant value. The rate of reaction of a zero order reaction will be like this. If concentration rate graph would be drawn in zero order reaction, the graph will be this. The rate is a constant value. If we increase the concentration or decrease the concentration, it doesn't affect the rate. The rate of reaction remains same at any concentration of A. So option B is correct. And at any concentration, the rate remains same. Okay. So option B is correct. The rate remains unchanged at any concentration of B and C. Okay, we don't know about the product part. We know about the reactant part. So option C is incorrect. Option D. Let's leave the option D because we already got the correct option that is B. So let's move on to next question. Half-life of a first order reaction is 4 seconds. So it is a first order reaction. But is given half-life is given that is T half is equal to 4 seconds. The initial concentration of the reactant is 0.12 molar. So initial concentration given is 0.12 molar. The concentration of the reactant left after 16 seconds. So after 16 seconds, what is the remaining concentration of reactant? If we notice, 16 is a multiple of 4. So T half, if T half is given, after every 4 seconds, the reaction, like reactant concentration would be halved. So let's write in this way, 0.12 molar. Okay. After 4 seconds, it would become, first 4 seconds, it would become half, that is 0.06 molar. After another 4 seconds, it would become 0.03 molar. After another 4 seconds, it will become half, that is 0.1015 molar. And after another 4 seconds, that is 4 seconds, 4 seconds, and 4 seconds, and 4 seconds, that is 16 seconds, it would become half of 0.015, that is 0.0075 mole. If whenever the time is given as the multiple of T half, you calculate in this manner. Okay. You do not need to go through the integrated equation part, that is log. Just simply halve the concentration after every t half. Okay. Or else you can write in this way: A is equal to A naught half into N. Here N is the number of half lives. Here number of half lives would be in 16 seconds. What is the number of half lives? 4 divided by 4 means 4. 4 half lives. So A is equal to A naught half into 4. Okay. So A naught divided by 16. Okay. A will be A naught by 16. Question number 33. The plot of concentration of the reactant versus time for a reaction is a straight line with a negative slope. That means, how is the graph? Straight line with a negative slope means this man. Okay. Like for the graph part, you have to remember every graph. Okay. For every order of reaction, you have to remember the graph. It is a graph of the concentration here, concentration time. Okay. Concentration is decreasing linearly. That means it is a zero order reaction. For first order, it will decrease as a exponential. Okay. So you have to remember the graphs. At last, if time permits, I will draw all the types of graphs so that you can remember easily. Okay. So for this question, the answer will be zero order. If you go with mathematics, what is the reaction formula? Rate formula of zero order reaction? That is C naught minus C gives rise to KT. That is C naught is equal to minus KT plus C. Sorry, C is given as minus KT plus C. If you can get the resemblance here, Y is equal to mx plus C. It is same that of C naught minus KT plus C. Here m is minus 1, so the slope is negative. Okay, so let's move on to next question 34. A substance A decomposes by first order reaction, starting initially of concentration A, that is 2 molar, after 200 minutes. 200 minutes. Becomes 0.15 molar. A becomes 0.15 molar. For this reaction T half. Okay. For T half, we need to find out the K value first. Okay. For T half, so write down the integrated formula: 2.303 log 10. A naught means 2. A means 0.15 gives rise to KT, that is 200 million. 2.303 log 10. If you solve this equation, I'm writing down the value directly. If you solve this reaction, you will get K is 1.29 into 10 to the power minus 2. Okay. From this, we get the value of K. Then T half would be 0.693 divided by K. That is 0.693 divided by 1.29 into 10 to the power minus 2. So the answer would be 53.72 minutes. Okay. Here I directly wrote the value of K. You just calculate in a rough paper and write down the equation. Okay. So option A is correct here. So let's move on to last question of this series. That is, select the rate law that correspond to data shown for the following reaction. A plus B gives rise to products. So let's analyze the reaction. Here, the equation given is A plus B gives rise to products. Experiment 1, in which point the concentration of A is 0.012, B is 0.035, initial rate was 0.1. If we, okay, let's compare equation like row 1 and row 4. If we increase the, like if we double the concentration of B, the initial rate becomes 8 times that of the final rate of reaction becomes 8 times that of initial rate of reaction. That means 3 B to the power means if you double the reaction of concentration of B, the rate is becoming 8 times. Okay. So 2 to the power Y is equal to 2 to the power 3. So Y is equal to 3. I'm not writing the whole equation, but till now you should have known the what is t to the power y is equal to 2 to the power 3. Okay, y is equal to 3. That is p to the power 3 for A. Now we have to find out for A. Compare row 1 with row 3. If we keep constant the concentration of B and double the amount of A, the initial rate and the final rate remains the same. That means the rate of reaction doesn't depend on the concentration of A. So the rate law would be written as Kp3. It only depends on the concentration of B, not on the concentration of A. So option A is the correct answer. Okay, option A is the correct answer. So with this, uh, let's end the session here. We have completed 35 questions of chemical kinetics chapter. Next, we'll see some organic chapters. Okay, thank you.